In this video we will start with our new project of BIW checking fixture. So here you can see we have the input, we have this part. For this part we have to design the checking fixture for this part. So first we will see what is the actual position of this part in the car line. So if you see this part parallel to y-axis, then you can see these are our default planes, and from these default planes this is the position of this part in the car line. So basically this is the actual position of this part in the car, and we have to design checking fixture at this position only. We don't have to move this part anywhere, we have to work at this position only. So when you get the input, you have to spend more time on the input. You have to observe this part very carefully. So if you see this part in ZX, so you have to check if there is any undercut or not. So there is no undercut here. Let's see the edges. So as you can see, this is a little tilted part, so you can see that lower edge, and on this edge there is lower edge is not visible, so maybe this portion is in undercut. There are chances of undercut on that edge, so we will see that, but deviation is not much. So if the degree is more, the deviation will be more. So we have to decide that, we have to consider that. So here deviation is the angle is very less, so the deviation will be very low. So this is a simple part, so we can design the fixture for this part very quickly. So first we saw what is the actual position of this part in the car, and we have to design the checking fixture at this position only. So we will take the front in ZX, which is parallel to ZX plane, and this is the back view, this is the side view. So we have to work on the top view. So we will consider the manufacturing feasibility and assembly feasibility. We have to design the checking fixture. Okay, so let's start working. So first, initially we need to work in the surfacing. So the surfacing, you should have very good surfacing skills. So here what I will do, I will create one axis first. So here you can see this is the absolute axis system. Okay, so we have only one hole for the locking, which means the chances of working 3-to-1 principle is very less. So you must know what is 3-to-1 principle. So I will just tell you, we have to locate all degrees of freedom of this part. So you know that any 3D part has 6 degrees of freedom, which we have to lock, and for that we use 3-to-1 principle, so that this part doesn't deviate from its actual position, and also we can maintain the repeatability for the other parts. So we can maintain the repeatability always for every other part. So we can lock this hole in the XZ direction, but for that, to lock the rotary motion of this part, we can take elongated pin as well. So if you take a same shape of pin, then it will not rotate about that pin. So within tolerance, according to nominal size, we will create a pin as per the shape of this hole, and then it will not rotate about that pin also. So I will simply rename this part as input data. So let's insert a geometrical set. So you can work in any type of geometrical set as per your company standard. Both geometrical set and order geometrical set has their benefits, has their own benefits of working. So okay, so I will work inside the ordered geometrical set because I prefer ordered geometrical set to work in the surface modeling. So I will simply rename this as surface. So this is the orientation of this part. So I will save this. So you have to keep saving every time. After a few minutes you have to save this. So you know all these surfacing commands. So we will use these commands to work in the surface modeling. Okay, so these are all different commands we have to use for specific purpose. Okay, so I will define this geometrical set. I have defined it and I will work inside this geometrical set now. So this is the top view of this part, and this is the side view of this part. So I will give you a general idea of how the fixture will look like. Okay, so I will take a snap and I will show you here. So this is the side view of this part, and we have to maintain 3 mm gap. And this will be the block. So in this way the fixture will be done. So there will be flush trim line. So if it goes above 3 degree, then we will deviate this. or if this is less than 3 degree, then we will simply extrapolate in the straight direction. So we will see that. So this is the general layout. So in the top view I will show you the locking. I will show you the pin locking. So this is the elongated pin. So this is the pin. So this direction is locked and this direction is locked, and it will not rotate also, because if the pin was round, then it could have there could have a rotary motion, but we are using elongated pin, so there will be no rotary motion. So we will consider this as a datum, because only we have this hole only. Otherwise customer gives you the requirement about that. Okay, so as per material, as per feasibility, we have to design the fixture. So I need to see what is the orientation in top view. So this is the orientation in the top view of this part. So according to that we will design this. We will work in the surface modeling. So here I need to extract a top surface first. So why we have to extract this? Because we have to offset this by 3 mm. So every time our part should rest at that position only, otherwise we will not be able to maintain the repeatability. So the part should rest properly at that position only. So I will extract the skin by using the extract command, and then I will simply offset this by 3 mm. So this distance is not, this gap will vary customer to customer. So this is the standard 3 mm I am keeping. So it may vary customer to customer. Now let's extract this for the flush. We have to maintain the tangency here while extrapolating. So I need all these 4 edges. So I will define this by giving different colors to different surface. So if there is some attached part, or this is in assembly, or below this there is some parts, then we can give the transparency to the surface. Okay, so I will just give this color to make it different, to make it easily we can easily identify it. So now what we have to do is we have to simply create the lower boundary so that we can extrapolate this in the lower direction by maintaining curvature continuity like this. So the minimum distance should be 50 mm. Ergonomically it is the safer distance for the checking fixture, so it should be 50. So here I need to take a large distance because I have to split this by taking 50 mm distance. Okay, so as you can see, we have created the complete closed surface. Now we will convert this surface into a solid body. So here I have inserted one body and I will rename this as, so we are using the SIBA material for this fixture, or MS, so we can use it is as per the customer requirement. So if we take any material, there will be two settings only. So if you want to save the machining setting for this undercut, so then we have to split this block and we have to do the individual machining for these separate blocks, because that face is in the undercut. So use any material, we need to split this block and then we have to do the machining, because that face is in the undercut. Okay, so let's make this solid now. Okay, so the fixture block is ready now. So I will insert one more body. And now we will create the bottom plate, or you can call it as base plate also. So the base plate will be below this block on which this SIBA material, SIBA or MS, it will rest on that base plate. So I will first change the color of the input so that for the easy identification. So now let's create one sketch. So as this is parallel to this plane, ZX plane, so we have to create a sketch on this plane now. Okay, so we will create one simple rectangle. So the value should be whole number, it should not be in decimal, and here we will keep a minimum distance of 75 mm. So whatever the external elements are going to fit, so for that purpose we need minimum 75 mm space. So in future, whatever for the template or for the clamping, for toggle clamps, if there is any plan of using these elements, then we need space for that, as well as for handling purpose also this space is required. So for the transportation we have to use the lifters, so for that purpose we will keep minimum 75 mm space. And all these distances must be whole number and there should not be any decimal value. So we have to make it nearby 75. So I have to maintain this distance. Okay, so now the profile is done. We will add the thickness to this. So minimum we have to use 20 to 60 mm as per availability in the market. So I will give the machining color on this face. So I will use magenta color for fine machining color. So I will add reference holes and tooling holes at 4 corners. So here what I will do, I will create one vertical and one horizontal axis for the reference, and I will make it symmetrical so that we can get the center of this plate. So these are the small tricks we can use to save our time. So I will simply create one rectangle on this corner, and then we have to just mirror this on the remaining 3 sides. So whatever change you done on this single profile, it will reflect on the remaining 3 features automatically. So in that way we can save our time. Okay, so we have to apply the radius on this corner of radius 20 mm, and now I will simply mirror this. Now we have to just create a pocket. We have to remove the material from the base plate. So here we can take 0.5 mm thickness. It is sufficient. So now what we have to do is we have to create the holes now. So the alignment is very important. So to create the holes, what I will do, I will delete these 3 and I will delete all these edges, and I will simply extract this center point because I need this point only, and I will mirror these points on the remaining 3 corners, and I got these 4 points I got. Now we can create the holes. So we have to create holes in one plane and in one direction only. And now I will user pattern this. And we have to save this from time to time. Now let's do work on the pins. So before that I will insert two bodies, one for the pin and one for the bush. So bush is for the guiding purpose only. So the bush is a female part and the pin is the male part. So bush is used for the checking as well as guiding purpose. So now I'm going to create one sketch. So the so the bush must be parallel to the surface. So I will create one plane tangent to this surface. So I need to extract this surface first. Okay, so I have extracted this and I'm going to create one plane on this surface. So now we have to create one point first, anywhere on the surface, at the center of this surface. So now we have to create the sketch in this way. Okay, so now we have to create the bush. Okay, so for that we have to create one sketch. So we have to add one circle for that. Okay, so here I will create one circle first. Okay, so here I have created two circles for the bush as per the standard. We will 6 mm is the inner diameter and 12 mm is the outer diameter as per standard. Now we will add material to this profile. So here you can see we have kept 16 mm height and now the bush is done. So now we will add the toggle clamp. So we will add one toggle clamp. So for that we need to go to assembly design workbench. So first we will insert the toggle clamp, which is a standard part. So we have to decide it by standard code, linkage and pressure. We have to decide the toggle clamp according to that. So here we have inserted this toggle clamp inside this part. So this is the vertical toggle clamp. Now we have to move this toggle clamp at the position of the resting pad. Okay, so what I will do, I will place that. Okay, so as you can see, this is the surface. These are the surfaces. So I will delete this. And I will just rename this, whatever is the standard name of this toggle clamp. So this is the standard name. So you will get this from the Mizumi standard. Or whoever is the provider of the toggle clamp, you will get from that. So the code will get changed according to the standard to standard, according to the customer standard. So first we will create one center point of this. So the part thickness is 0.7. So I will create one point at the center of this circle. And I will create one axis on this point. So the position is important for the axis. Okay, so now I will create one geometrical set of name toggle clamp axis point. So inside this we have to generate the toggle clamp axis point. So we have to the center of this resting pads. So we will create points at the center of this resting pads. Because the block is 8 by 12. So I have created, I will create a center point of this resting pad. So the block size is 8 by 12, so it should be 4 by 12 to get the center of this resting pad. translate this. Like this. So here we need to increase the length of this base plate so that the clamping is properly will rest on this resting block. So now we will add the riser blocks. For these toggle clamps. So for that we will simply create a rectangle. Now we will pad this profile. So let's insert one body and let's define this body, and then we have to add this profile. So I will rename this as toggle clamp riser. Okay, so I will simply extrude this up to this plane. And in this way we have created this toggle clamp riser. So there is one exercise for you for the screwing, how to do the screwing. So in the same way we have done the screwing, so in the same way we have to do the screwing for this. So this is the exercise for you. Okay, so now we have to just create a rectangle. So we need to increase this plate a little bit more. Okay, so this is sufficient, I think. Okay, so let's create one rectangle for the second riser block. Okay, so now we have to just pair this profile up to this plane, and now it is done. Now in this way we have created this toggle clamp rises. Now the screwing and tapping work we have to do, that is the exercise for you. So in this way we have completely designed the checking fixture for this part. So these are toggle clamps are standard parts, so we have to order this as per customer requirement or as per the standard catalog. Then we have to decide the manufacturing process, machining process, and in this way we have completed this project.